All right, we're solving two-step inequalities today. Let's read the directions. Solve each inequality and graph its solution. So the first thing that we're going to do is solve these. They solve pretty much just like equations do. Now, there's not room because there's a number line in the middle of this to just solve it right here. So the first thing that I am going to ask you to do is to copy the problem below the number line. Everyone should be doing that right now. Take a second, copy the problem below the number line. I want you to do that on the homework as well. That's a direction that I'm giving you. Okay? That way this will be nice and neat and I can actually follow your work. So pretend this is an equation and that this has an equal sign. I want to get the part with k by itself, which means I need to get rid of plus 8 first. How do I do that? Rhett? Minus 8. We do the opposite, and we do it on both sides, and we show the work on both sides, because that proves that this is going to go away. All right, and then we have 10k is greater than, and over here, this would be 190. Now, I've got the term with k by itself. I just want to get rid of the 10, which is the coefficient. Raise your hand if you know how to do that. Johnny? Divide by 10. Very good. Okay, so this one, there's nothing really weird. We're just going to solve it just like we would an equation. And we get k is greater than 19. So I'm going to box that. That is my solution. Instead of an equation where there's one number that's a solution, every number that goes here, which is bigger than 19, is a solution. There's an infinite number of solutions. How do I graph k is greater than 19? Raise your hand. Silas, is your hand up? Oh, okay. Who else wants to go? Go ahead, Tommy.
What was the question?
How to graph this.
Oh, you put a circle around 19, but don't fill it in.
Okay, so circle at 19. Why aren't we filling 19 in?
Because it doesn't have the line.
Oh, because it doesn't have the equal to line. So 19 doesn't actually count. 19 is not greater than 19, so it's sort of like a little hole in the graph. And then where are the numbers that are greater than 19? Are they left or right? Go ahead.
To the right.
To the right. So all of these numbers out here to the right would make this true. Everything bigger than 19, starting with 19.00000001, is just barely bigger than 19. Okay? So everything to the right of 19 is a solution. Now, we talked a little bit last week about a test point. If you're worried you may have screwed something up in here, one of the things that you can do, if you're pretty sure you did the math right and the numbers right, but you're not sure if you shaded the correct side, you can pick a number over here and put it in for k. So like I might pick 21 and just try it. Is 21 greater than 19 true? It is. And so I know that I shaded the correct side. So if you know you did the number part right, but you're not sure, was I supposed to flip this? Did I shade the correct part of my graph? Whatever. You can use a test point and check that. Some of you last week, when I was looking at things, did okay solving this, but then you shade the wrong side. So that test point is a really good way to just check and make sure I've got the right set of solutions. Okay, let's go over to number 2. So first thing I want you to do is copy the problem down here. I know that's a pain in the butt, but it takes like 2 seconds and then it's done, so just do it. What would be my first step for solving for k? Jaden?
Plus 3.
Plus 3, good, because that gets rid of the minus 3. And that leaves the term that has the k in it by itself, which will make it easier to solve for in a minute. So I have negative 78 plus 3, that would be negative 75, because this 3 cancels out 3 of the negatives. But we have more in the negative direction than we do positive. Okay, how do I get k by itself now? Winter. Divide by 5. Divide by 5. Does anybody know what 75 divided by 5 is? Go for it.
15.
15. Good. And then is it going to be positive 15 or negative 15? Negative, because I have a negative divided by positive. They've got different signs. Good. So k is greater than negative 15 is my solution. So I'm going to box that. This is the first thing that we check when we're grading. And then we go up to the graph. So at negative 15, it's not marked, but it would be between negative 14 and negative 16. So right here, We're going to put a circle, and it's greater than again, so the numbers that are greater than go to the right. So these are all the numbers that are greater than. I always think negatives are a little harder to check if you use a test point because you have to really think about it. But if you know that greater than numbers are to the right, that works. And we talked a little bit about last week that if the variable is on the left-hand side, the symbol is actually supposed to look like an arrowhead. It points you the direction for the solutions. Although if they put the variable on the other side, it gets a little tricky. We'll do one of those in a little bit, and I'll go through that. Okay, so first couple of basic examples. Let's go down to number 3. Lots of negatives on number 3. So let's copy down the problem so that we have room to work. The other thing that's different on number 3 is we have not just less than, but less than or equal to. They have that little line underneath. And so we've got to pay attention to that. All right, so we're solving for B. What's my first step? Okay, make sure to raise your hand. Try that again. Raise your hand. Good job, Tommy. Plus 1, because that's going to get rid of the minus 1. Okay, so I have negative 4b, and if I have negative 69 and a positive 1, that positive 1 cancels out a little bit of that. Negative 69 leaves us with negative 68. And then what's my next step? Jaden.
Would you divide by negative 4?
You would divide by negative 4. That's how we get the coefficients off of the variables, is by dividing usually. So that gets rid of this, leaves b alone. Now, we divided by a negative. So I'm going to put a little star next to that. We need to flip the symbol because we divided by a negative. So if it's less than, we're going to change it to greater than. And then I have to take negative 68 divided by negative 4. First off, is the sign going to be positive or negative?
Positive.
Positive. And then
it's 34.
30. No.
17.
What is it?
17.
17 sounds a little bit better. I think you're divided by 2. Okay, so we've got b is greater than or equal to 17. So don't forget, when you're dividing by a negative, what it does is both of these were negative and it changes them to positive. It just reverses pretty much everything in the problem. What's different about the graph when I have this little bar there? Red.
You fill in the number.
You fill in the number. So at 17, I'm going to fill in that point, and then I'm going to shade everything to the right, because those are where the numbers are greater than 17. If you look, this is an arrowhead pointing to the right. My arrow is going to point to the right. So all of these numbers would work. If I put 19 in there, that's bigger than 17. And 17 gets to be counted as a solution because we have that little equal to bar. They have like half of an equal sign that goes with the greater than symbol. Okay, let's go on to number 4. So number 4 looks a little different. We haven't done a lot of these, but we actually do know how to solve them. So we'll go ahead and go through it. So I took a moment to copy down the problem. Take a second if you need to do that. What would be my first step? What do you think? Go ahead.
Minus 7.
Minus 7, just like it is with the others. Even though that's that weird fraction in there, you still start with the addition and subtraction and get the part that has a in it by itself. So if a over 5 is greater than 2. Now, how do I get rid of a divided by 5? Let's see if somebody... Sam.
Divided by 5.
Well, it's already divided. So what's the opposite? Multiplied. Good.
Yeah.
So if it's divided by 5, what we're going to do is we're going to multiply by 5 on both sides. And that will cancel this out and leave a by itself. Over here, I would have 2 times 5, which is 10. So remember, when we're solving equations, we're always using the opposite operation. And I realize this isn't equations, it's inequalities, but the steps are the same. So if I have a is greater than 10, when I go to 10, do I fill in the circle?
No.
No, because I don't have that equal to part. So 10's not actually part of the solution, which is why it looks more like a hole than it does a point. And then which direction do we shade? Okay, so say it's to the right. Good job. So we're going to shade everything to the right, because that's where the numbers are bigger than 10. And if I take a number, like let's say I try 15, and put it in there where a is, and I go, okay, did that work? Is 15 bigger than 10? Yes. So if I'm pretty sure I did all the math right and that the 10's right, You can check and see if I shaded the correct side by picking a point on the side you shaded and go, okay, yeah, that's where my solutions are. Those numbers are bigger. It's okay. All right, let's look at number 5. So on number 5, we're going to start by just writing the inequality down here. It's not an equation, it's an inequality because it's not equals. And what would be my first step? Go ahead.
-8.
-8 from both sides. Subtract 8. Okay, so that gets rid of the +8. That cancels and leaves us with 0. And then we get n over 4. Sorry, I keep breaking my lead. And then I have is less than 11 minus 8 is 3. So somebody who hasn't answered, volunteer. I guess you've only done one. Winter, what would I do next?
You would multiply by 4.
Multiply by 4. Good job. Multiply by 4. Multiply by 4. N is less than 3 times 4, which is 12. So here's my solution. And then on the graph at 12, do I fill it in? No, because it doesn't have an equal to bar. 12 is not actually part of the solution. It's just where I start my arrow. And then see how this is pointing to the left? That's less than. All the others so far have been greater than. Here's where those numbers are that are going to make it true, is to the left. If I pick any number along here, like 8, 7, 6, 5, 11, those are all smaller than 12. Those all make this true. All right, we've got one more. It's a little trickier, so I'm going to take a little bit more time with it. So on number 6, I'm going to just copy the problem down as is. Okay, so the variable's on the right-hand side this time. It doesn't solve any different. It's totally fine. I want to get the part with b in it by itself. So I want to get rid of this -7. How do I do that? Go ahead, Tommy.
+7.
+7. I want to use an opposite so that it actually creates a 0 there. You want to think of it as opposites making 0. And then I have -12 plus 7, so that would be -5. And I have is greater than b over 4. What would I do now?
You would do times 4.
Okay, multiply by 4, multiply by 4, and that cancels out the divide by 4. And I have b on this side and -20 over here. I can box that. That's totally my solution. If you're relying on this to tell you the direction, though, you might want to not do that. We can flip this whole thing around if you're more comfortable and put b on the left and -20 on the right. If you do that, this, if you're thinking of it as an alligator, still needs to be eating the same number. So if it's eating the -20 here, it needs to be eating the -20 here. I don't care how you write the answer. Either way is fine. A lot of people do better when they write it this way, because then this arrowhead shows you which way the graph's going to go. So we put our circle at -20, and then we shade to the left. The left is where all the numbers are that are less than -20.